Hi guys, welcome as we do this problem. Guys, I read the question first. And here is the question. Given that 1 plus kx into bracket raised to n is equals to 1 plus 48x plus 108x squared, where k is a constant, find n and k. So guys, here is the question. And guys, the first thing I want to do is to express or to write down the formula for the binomial theorem, binomial expansion. And if I have a formula like this, let's say I use that formula. I used x because this one already has x. So guys, this one gives us 1 raised to, this is n, 1 raised to n plus, here guys we are going to write n, and then 1 again raised to n minus 1, of which 1 raised to any number will still be 1, and so I can leave the 1. And so I continue on now to bx. So we shall have here bx. This is now raised to 1, and this now comes to 1 factorial. From there, guys, the next term, we shall have n minus 1 all over 2 factorial. Then we have the 1 we are talking about, but since 1 will remain 1, we can go to bx. So we have bx. Now this is now squared. So guys, that is our formula. And since we are reaching up to x squared, guys, we can also reach up to that point. So now guys, we now come to our equation, whereby we have 1 plus kx. This is raised to n. And so this one will now come to 1 plus, here we shall have n. And then instead of b, guys, we are going to have k. So this is now going to be kx raised to 1 all over 1 factorial. And the next term, guys, we are going to have n minus 1. And then here we have kx squared. All that is squared all over 2 factorial. So guys, up to there, all is well. So guys, now we come and equate this term and this term, this term and this term. And this is because, as you can see, we have here 1 plus 48x plus 1008x squared. Actually, we are equating to this term. Let me just write it here. 1 plus kx now raised to n. Guys, this should give us 1 plus 48x plus 1008x squared. So guys, this is the term I meant when I said this and that. It's actually this term and this term. And so therefore, guys, as you can see, the coefficient of x here is 48, which should be the same as the coefficient of x at this point. And so therefore, guys, we shall have n k for this. This now should be equal to 48. Coming to this other term, this term, the coefficient of x squared, which is 108, should be the same as the coefficient of this term. And this one now comes to n over n minus 1. Then we have k squared all over 2 factorial, which is the same as 2. This should give us now 1008. So guys, that's the equation we shall be solving, the equations we shall be solving. And therefore, guys, we can actually write this, and this we can do it by, we can take this number on this other side. So that, guys, we now have n. Here is n squared k minus nk squared. This is n squared k squared. This one, the other one, when we now expand that, we get n k squared. This now gives us 1008 multiplied by 2. This comes to 2016. From there, guys, we can come here and modify this equation. And this is how we modify this equation. We shall have n k squared. And this one is the same as that. Then we say minus n k. We can put a bracket there and then put k. Guys, I have not changed anything. It's still the same as that. This is equals to 2016. And so therefore, guys, we can now come and apply this in this equation. So this is now going to be 48 squared minus 48k. This now gives us 2016 like that. And so therefore, guys, we can now evaluate for k. And therefore, k can remain on this side, minus 48. K is now equal to 2016 minus 48 squared. 48 squared is 2304. And so therefore, on this side, we are going to have 2016 minus 2304. That is 2304 minus 2016. This gives us 288. And for this one, it shall be negative 288. So this is negative 288 because this is bigger than this number. And here we have 48k. Guys, from there we can cancel negative and negative and then divide this side by 48 and this side by 48. And so therefore, guys, our k then will be equal to 6. So guys, we are able to find k. And now, guys, we can also find the value of n. Since we have nk equals to 48. And so the value of k, here we have 6. And here we have n. This is equals to 48. Therefore, value of n is actually equal to 8. And so these are our solution, guys. Thank you for listening to me. Bye.